or 10.5 inches over the 12 inches. That's the conversion. I'll show you why that is, but just to be quick and here, I was just going to do it that way. So this is how you do it. 10.5, which would be 10.5 inches, divided by 12 is 0.875. So really, I just have to put 4.875. Now that is in feet, so let's just carry this all the way down. That's what I like to do. So now I got to convert this into inches, because remember, this is in inches still. So I'm just going to carry this one down again. 12 equals x over. Now we have 4.875 times 12 inches per foot. That's 58.5 inches. And then now it's just cross multiplication. You go 58 times 9. And then divided by 12, and then you get your final answer. 1 sec. Divided by 12, you get 43.875. And this number right here is this number right here, where the rafter meets the ridge, all the way down to this level line. That's basically where the plane is of where the plywood meets the rafter on the outside of this wall. So knowing that, that's my height now, I can determine quite a number of things actually with that. Now I know everything. If all the limiting factor is this wall going to be sitting on a bird, does it need like a relief cut or a bird's mouth cut or whatever you want, a level cut, whatever you want to call it, there. But for this example, let's just assume that, I don't know, the height above plate, it's a 2x whatever rafter, but this number right here is irrelevant. It depends on your zones of what your R value needs to be. My variables now, the rise and the run of this rafter. So let's go rise equals 43.875 and run equals 58.5, and then we can use that into the Pythagorean theorem equation, the c squared, everyone knows it, a squared plus b squared. So these are the limits of that triangle. Now we made the a squared and the b squared, and then this would be c squared. So plugging that in, let's see if I can use my calculator. It would be 43.875. How do I? Is this to the power of? I think so. Anyways, I'm gonna put a bracket on this one, and then plus 58.5 to the power of 2 bracket, and then so that's the order of operations. Now I gotta square root it, so I gotta add another bracket here like that, and then all of this gets square rooted to 73.125. So what we just did there was calculate where this point of the rafter is. Remember, it runs along the outside of the wall. We're calculating the distance from here to where it meets the ridge. So now you know that that is your rafter. And really quickly, just to show how that relates, I'll use it on the calculator here. So knowing just this and the pitch, so all I do is I input my run, which is 58.5. So I go 58 inch 1/2, and that is the run. And then I go 9 inch pitch diagonal, and I get 73 1/8, and that confirms this number right here. 125 is 1/8, exactly.